Hello students, welcome back in our session. So in today's session, we will be seeing NCERT exercise 1.5. Okay, let's begin. A disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Okay, and I hope from yesterday's class everything is clear. Okay, so moving on to this. Here's our question. We are given with universal set U with 9 elements, first 9 natural numbers. Another set A with 4 elements 1, 2, 3, 4. Another set B with 4 elements 2, 4, 6, 8. Another set C with 4 elements 3, 4, 5, 6. And we have to find out A complement, B complement, A union C whole complement, A union B whole complement, A complement then complement, B minus C whole complement. Either you can use your definition or properties, just answer the following questions. Clear? So I'll be providing you with some time and then we will be seeing the answer afterwards. So your time starts now. I hope most of you got the correct answers, as I can see. Yes, you are getting the correct answers. Now, so for first solution, so A complement is simply what? You have to form a set in which you have to collect elements which belongs to the universal set but not in A set. Okay, or in you can also see from the perspective of different set that A complement is U minus A. So A complement will be your what? Sets with 5 elements 5, 6, 7, 8, 9. Clear? B complement. So B complement will be elements from the set U and eliminate all the elements which belongs to the set B. So 2, 4, 6, 8. Eliminate 2, 4, 6, 8. You left with 1, 3, 5, 7, 9. 1, 3, 5, 7, 9 set will be a B complement set. For third, first of all, find the union A union B. In A union B, you will have all the elements from set A as well as from set B. Okay. Now, complement of A union B is very simple. Find out the elements from set U which do not belongs to either set A or set B. So, eliminate 1, 2, 3, 4. Eliminating 1, 2, 3, 4. 2, 4, 6, 8. 2, 4 already been eliminated. Now, 6, 8. You only left with these 3 elements 5, 7, 9. Clear? So, here we are talking about A union C. So 3, 4, 5, 6. So eliminate 3, 4, 5, 6. So you only left with these 3 elements 7, 8, 9. So A union C whole complement will be your set with 3 elements 7, 8, 9. I hope the approach is very clear and easy to find out the complements. Okay, if someone facing any difficulty finding out difference, union, intersection, complements, etc., please let me know. Now, fourth, A union B whole complement. So, A union B. So, first of all, form your A union B set. In A union B, you will have elements 1, 2, 3, 4, 6, 8. Clear? Now, eliminate all these elements from set U. So 1, 2, 3, 4, 6, 8. You only left with 3 elements 5, 7, 9, and collection of these 3 elements will be your A union B whole complement. For fifth, A complement, then again complement is very simple. If you recall the properties of complement, which is A complement is A itself. Yes. So A complement is A itself. Now for the last, B minus C whole complement. So first of all, find out B difference C. So what do we mean by B minus C? Can anybody give me the definition? B minus C. So B minus C is simply collection of all elements of the set B which does not belongs to set C. Clear? Yes, all that's in B but not in C. Correct. So B minus C will be your set. So in order to find B minus C, it's very simple. Write down the complete set B and then eliminate the common elements which belongs to C. So eliminate 3. 3 doesn't belong here. 4, 4, 5, 5 not present here. 6, eliminate 6. So B minus C will be your set 2, 8. Now the complement of B minus C very simple. Eliminate 2 and 8 from the universal set. So eliminate 2 and 8. You left with 1, 3, 4, 5, 6, 7, 9. So this set will be your B minus C whole complement. Clear? So A complement, and then again complement is very simple. So you know from property that complement of A complement is simply A. So this will output as A. Now A complement. So the output will be A complement. Clear? Yes, indeed. A complement is our answer in this case. Okay? Clear? Now moving on to next. This question. Here universal set is given to you with these elements A, B, C, D, E, F, G, H. You have to find the following complements. So for first, if A set is with 3 elements A, B, C, find out its complement. In second, B is D, E, F, G, then find out its complement. In C, if set is A, C, E, G, if D is your set with elements F, G, H, A. Clear? I hope the question is clear. Here, I am providing you some time to try this problem. Then afterwards, we will be seeing the solution. Okay? So your time starts now. The time is up. Yes. One way to interpret the information is like this. The number of complements is even. Then you can say the output will be your actual set, original set. And if you got odd numbers of complement operations, then the output is complement. Yes. Now, focusing on this. Very simple. Solution. So for first, A complement is quite simple. So you just have to collect all the elements from the universal set which does not belongs to A, or eliminate all the elements from the universal set which belongs to A. So eliminate A, B, C. Eliminating A, B, C, you left with these 5 elements D, E, F, G, H. And collection of these 5 elements will be your A, what? A complement. Clear? Now, for second, eliminate these 4 elements D, E, F, G. The leftover collection will be your B complement set. So eliminate D, E, F, G. So you left with A, B, C, H. This collection will be your B complement. Clear? So B complement will contain 4 elements A, B, C, H. Now, Third, if C is your set with 4 elements A, C, E, G, then C complement will be very simple. Eliminate these A, C, E, G 4 elements from the universal set A, C, E, G. You left with these 3 elements, not 3 or 4 elements B, D, F, G. So collection of these 4 will be your C complement. Clear? Now for fourth, eliminate elements belongs to D from set U. So after eliminating F, G, H, A, you left with these 4 elements B, C, D, E. B, C, D, E. So collection of these 4 elements will be your D complement. Clear? I hope how we got our answer is clear to you. Anybody having any doubt, issues? So moving on to next. This question. Taking the set of natural numbers. So here we are taking universal set as set of naturals. Clear? Then we have to find out complements of the sets described below in set builder form. So here we are given with 5 different sets in set builder forms. So we have to find their corresponding complements. Okay, I hope question is clear to you. So in first, this set is collection of all even natural numbers. Second, collection of all odd natural numbers. In third, collection of all positive multiples of 3. In fourth, collection of all prime numbers. And in fifth, x is your natural number and divisible by 3 and 5 both. Clear? So you will have some seconds, try it, and then we will be moving on to the solution slide. So your time starts now. The time is up. So I hope the question is clear to you. So moving on to the solution. So for first, very simple. If you are collecting all the even natural numbers, then the complement will be your what? If provided the universal set is natural numbers. So eliminate all the even numbers from the universal set. You only left with odd numbers. Clear? So the complement for set provided in first is just simple collection of all odd natural numbers. Clear? Now for second, here you have been provided with collection of all odd natural numbers. The set in which you are having collection of all odd natural numbers. If you eliminate all odd natural numbers from the set of naturals, you only left with even natural numbers. So in second, the complement will be collection of all even natural numbers. So far so good. Now for third. Here in third, you are described with the collection of positive multiples of 3. What? Positive multiples of 3. Now the complement will be very simple. So you have to eliminate all the positive multiples of 3 from the natural numbers. So simply you will get what? Not multiples of 3. Simple. X belongs to natural and x must be not a multiple of 3. Clear? I hope this is clear. How we are describing our set builder form for complement sets. Now for fourth. In fourth, we describe the set as collection of all primes. Collection of all primes. So very simple. So first of all, write down what do we mean by primes and composite numbers. Can somebody answer? Primes. What do we mean by primes? Comment. And composite numbers. Fast. Very simple. Yes, those who have exactly two factors, one and the number itself, then we say that number is a prime. What about composite number? Those who have more than two are composite, yes. Here, one thing is happening. What? One interesting thing. If you eliminate all the prime numbers from the set of naturals, what will be the leftover set? What will be the leftover set? Composite. So the answer is not completely the composite numbers. Because what about the 1? Is 1 your composite number? By definition. So do not forget to include the number, natural number 1. Yes. So you have to explicitly mention in your set builder form that we are including 1 here, because you are what you are trying to do is simply removing all prime numbers from the natural number set. So you left with composite number plus this number 1. Clear? So your complement for the fourth will be collection of all numbers such that your number is a positive composite number, or it could be 1. Okay? I hope the fourth part is clear. The answer. Anybody having any difficulty? Okay. Moving to fifth. So fifth is very simple. Here the set described as collect all natural numbers which is divisible by 3 and 5. So we are dividing or we are collecting such numbers, those divisible by both numbers 3 and 5, meaning we are collecting here multiples of 15. If you try to observe here what is happening, we are collecting numbers which are multiple of 15. Okay. So what you have to do is simply do not collect. So the complement will be what? Very simple. So here the very simple, the collection would be your multiples of 15. Simple. Because multiples, every multiple of 15 will be divisible by 3 and 15. We are using this word and, meaning you have to collect elements or natural numbers which are divisible by both 3 as well as 5. But in complement, you have to select a number which are not going to divisible by 3 or 5. So you have to select a number from the natural numbers in complement that your number must not be divisible by 3 and 4 simultaneously at the same time. Yes. So here we are using the word or. Clear? So collection of all positive integer which is not divisible by 3 or not divisible by 5. Clear? Okay. Simple. Okay. I hope this is clear. So one way to describe the same set, fifth set. Okay. I hope this is clear. Now, moving to next. This question. Taking the set of natural numbers as a universal set, write down the complement of the following sets. Simple. So you have to write the complements of the following sets. So in sixth, collection is all perfect square. In seventh, collection is perfect cube. In eighth, collection of all x satisfying the equation x plus 5 is equals to 8. 9 collection of all x satisfying the equation 2x plus 5 is equals to 9. In 10 collection of all x, x greater than equals to 7. And in 11 collection of all x says that x belongs to a set of naturals and 2x plus 1 is strictly greater than 10. Clear? So you'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So I hope most of you getting the answers. So solution, you can verify your answer here. So for sixth, the complement will be the collection of all natural numbers which are not a perfect square. Simple. Which are not a perfect square. Now for seventh, the complement for the perfect cube set will be all natural numbers which are not a perfect cube. Clear? Straightforward answers. For eighth, here we are collecting what? All natural numbers satisfying x plus 5 is equals to 8. Meaning 3. 3 is the only number, natural number satisfying the your equation. But in complement, you are collecting what? All natural number except 3. So, collection of all natural number except 3. Clear? Okay. So, now for ninth, here we have collected x satisfying 2x plus 5 is equals to 9. Meaning, in this collection, you will have only 2 singleton set. This will be your what? Singleton set. Now, what we are trying to do is to find the complement. Very simple. So, you are collecting all the natural number except the solution for this equation. So, solution for the equation is simple 2. So, we are collecting all natural number except 2. Clear? Yes, we can write like that the x plus 5 not equals to 8 in 8th. Another way to represent the same thing. X belongs to set of naturals set not satisfying the equation. Simple, not satisfying the equation. Meaning x plus 5 not equals to 8. Okay. Now for 10th, in this collection we are collecting all natural numbers equal to 7 or greater than 7. In its complement, we have to collect all natural number strictly less than 7. Simple. Clear? Now for 11th, observe carefully the set. So collect all the natural numbers satisfying the given equality. So inequality is 2x plus 1 is strictly greater than 10. Clear? Now if you solve for this, this will be what? X strictly greater than 9 by 2. Yes, this will be your x strictly greater than 9 by 2. Meaning you are collecting all your natural number strictly greater than 9 by 2, meaning so this is your 4.5. Yes. So meaning you are collecting all the natural numbers greater than 4.5. Okay. Now in its complement, we have to collect all the natural number less than or equal to 4.5. Yes. So your complement set will be what? X such that x belongs to set of naturals and x less than equals to 9 by 2. Clear? So, yes, if in this complement, if you try to observe carefully, we are collecting what elements? Here, So we are having 1, 2, 3, and 4. Yes. If you write another set builder form for this, another will be very simple. So just collection of all x belongs to set of naturals and satisfying x strictly less than 5. You can write in this manner also for its complement. Clear? So you have to explicitly mention that we are collecting x from the naturals. Okay? And x is your strictly less than 5. Clear? These both two different set builder form represents the same thing, same set. Okay? Moving to next. I hope all clear. Okay, moving to next. Now this question. Here we have been provided with universal set A and B as their subsets. So universal set collection of first 9 natural numbers. A set with 4 elements 2, 4, 6, 8. B set with 4 elements 2, 3, 5, 7. What we have to do is we are provided with two statements and we have to verify them using these universal set A and B. Okay. So in first, A union B whole complement is same as saying A complement intersection B complement. And in second, A intersection B whole complement is equals to A complement union B complement. I hope you recall the name for them. What is the name for these laws or properties? We have seen a Venn diagram proof for these two also. Yes? So you'll have some seconds to try this problem. Then afterwards, we will be moving to the solution slide. So your time starts now. The time is up. Very simple to verify. So solution. So starting with the given information, universal set with 9 elements. A and B set with 4 elements in each. Now for first A union B whole complement is very simple. Find out the A union B. A union B will be your set in which you are collecting all the elements from set A as well as from B. So collect 2, collect 4, collect 3, collect 5, collect 6, collect 7, collect 8. So you will have this as your A union B. Now the complement. The complement will be very simple. Eliminate all these elements from universal set. So eliminating 2, 3, 4, 5, 6, 7, 8. You only left with the two elements 1 and 9. So the collection of these two elements will be your A union B whole complement. Clear? Now find out this right hand side, A complement intersection B complement. So first of all, A complement is very simple. Eliminate all the elements which belongs to A. So eliminate 2, 4, 6, 8. So eliminating 2, 4, 6, 8. So leftover set will be your A complement 1, 3, 5, 7, 9. So 1, 3, 5, 7, 9. Now B complement will be eliminate 2, 3, 5, 7 from the universal set. 2, 3, 5, 7. Collection of leftover elements will be your B complement set. So B complement set. Okay, now the intersection meaning collect the common elements from the both sets. So common elements 1 belongs to both, 9 belongs to both. So the intersection will contain exactly two elements which are 1 and 9. And as you can see, both A union B whole complement and A complement intersection B complement gives me the same set. So both are equal. So what we are going to conclude is A union B whole complement is same as A complement intersection B complement. Okay. Now for second, A intersection B whole complement is very simple. So A intersection B meaning collect common elements from set A as well as from B. So common elements only one, meaning this two. So you get your A intersection B as your singleton set. Now the complement for this singleton set will be very easy. Just eliminate 2 from the universal set. So eliminating 2, you are left with these 8 elements, and collection of these 8 elements will be your A intersection B whole complement. 1, 3, 4, 5, 6, 7, 8, 9. Clear? Anybody facing any difficulty? So what about A intersection? Sorry, A complement union B complement. Very simple. Find out A complement. A complement is very simple. Eliminate all the elements which belongs to A. So 2, 4, 6, 8. 2, 4, 6, 8. So the leftover collection will be your A complement set 1, 3, 5, 7. Now for B complement, very simple. Eliminate all the elements of B from U. So to eliminate 2, 3, 5, 7, you left with these 5 elements, and the collection of these 5 elements will be your B complement. Now the union of these A complement and B complement will be collection of all elements from A complement and B complement. Very simple. Collect A, collect 3, collect 4, collect 5, collect 6, collect 7, collect 8, collect 9. So the collection will be your what A complement union B complement. And if you try to observe carefully, you will find that what the complement of A intersection B is same as A complement union B complement. Okay, I hope the this verification part is clear to you. So moving to next, this question. Here we have to draw appropriate Venn diagram for each of the following. So for first, A union B whole complement. For second, A complement intersection B complement. For third, A intersection B whole complement. And for fourth, A complement union B complement. You'll have some seconds to try this problem, and afterwards we will be moving to solution slide. So your time starts now. The time is up. Very good. We are going to shade everything except the 2 circles for A and B. Correct. Now let's see solution for those who have not got the answer. So for first A union B whole complement, let's see. So for first, as you can see, for first, what we are doing is, first of all, find out your A union B. So A union B is your area shaded by these two, combined area shaded by these 2 circles A and B. Now eliminate the shaded area. Now the area for A union B whole complement is very simple. Shade everything except the area covered by these 2 circles. Okay. Now for second, A complement intersection B complement. So for 2 and 1 both same. Yes, indeed, because they are following. What can you name the property or law? So first of all, for A complement, so A complement is simply shade every area except the A circle for A complement. For B complement, shade everything except the B circle. Now the intersection meaning common shaded area will be this. And if you try to observe from both of these, both are the same. and these there's a name for them. What name? De Morgan's law. Okay. Now for next two, solution. So third, A intersection B whole complement is simple. So for A intersection B, first finding out the intersection B is this part. A intersection B meaning common part for both the circles A and B, common. Now the complement is simple. Shade all the part except the shaded, already shaded part here. So you will get A intersection B whole complement like this. Okay. For third, it is clear. Now for fourth, A complement union B complement. Very simple. Find out A complement, find out B complement, and union both. So A complement is simple. Shade everything except the circle A. For B complement, shade everything except the circle B. Now union will be, you have to just simply shade everything except the common part. So common part which is not shaded is this. So shade everything now except the common part. So you are getting your A complement union B complement like this, and both are the same. Okay. I hope the all four Venn diagrams for four Venn diagrams are clear to you. Moving to next. This question. Let U be the universal set of all triangles in a plane. If A is the set of all triangles with at least one angle different from 60 degree, then what is A complement? Simple question. If you are having your universal set, collection of all triangles, and A as a subset of U described as set of all triangles with at least, so we are having at least one angle different from 60, at least one angle different from 60, then find out the complement. You'll have some seconds to try this problem, then afterwards we will be moving to solution slide. So your time starts now. The time is up. So very simple question. Solution. So you described a set of all triangles in a plane, and A set of all triangles with at least one angle different from 60. So in A complement, you have to collect what type of triangles you have to collect, where in which all the angles are of exactly 60 degree. And another way to put the same thing is to say that we are collecting equilateral triangles. Indeed, you are giving me the correct answer. Equilateral triangle. So simple. A complement will be a collection of all triangles with all the three angles of 60 degree. So set of all equilateral triangles. I hope this is clear to you all. Okay, moving to next. This question. So in this, we have to fill in the blanks to make the each statement true. Okay. Now, is it clear? My voice? What about now? Still low? Are you getting or not? Please comment. Okay. So what about now? Okay. So, so for first, A union A complement. For second, pi complement intersection A. For third, A intersection A complement. For fourth, U complement intersection A. So you have to make each of the following true. So fill up the blanks. Very simple. We have already seen such problems. So you will have some seconds to try this problem. Then afterwards, we will move on to the solution slide. So your time starts now. Most of the students giving me the correct answer. Now let's verify them. So you have to fill in the blanks in order to make the statement true. Solution. So for first, it is quite simple. A set and the complement set union will be your universal set itself. Why? Because in set A, it is already described, and A complement, you are collecting all the elements of universal set which does not belongs to A. So if you try to see, this says what, that we are collecting all the elements which belongs to A as well as which does not belongs to A, and that collection will be of what? Universal set. Quite simple. So simple. From a Venn diagram, if this is your A, then outside the circle A will be your the complete A complement. So unioning, so if you union both A and A complement, the complete set will be the universal set itself, represented by this rectangle. Okay. Now for second, phi complement intersection A. It is same as, so first of all you must know about phi complement. So what is phi complement? It is universal set itself. So now the question is to find a U intersection A. And you know, when you have a subset for another set, in this case U, then the intersection will be what? Your subset. Okay? U intersection A is simply A. Why? Because phi, so we are getting what? Therefore, phi complement intersection A is simply A. Okay? Now for third, A intersection A complement. So by definition, we are collecting, what we are trying to do is, we are going to find, or we are having a task in which we are going to find common elements from set A as well as from set A complement. But by the definition of A complement, which says that in this set we have to collect elements which belongs to the universal set and which does not belongs to the set A. So we are not going to be get any, so we are not going to get any common elements from both the sets, so intersection is empty. Okay, both sets are disjoint. Now U complement intersection is empty. Why? Very simple. U complement is simply your empty set, and empty set intersection A is your empty. Okay, U complement is your empty. And you know, empty set intersection with any other set, say A, will be your empty, because phi is your subset of A. Okay, I hope the all the question we have discussed with solutions are clear to you. Okay, So this is it from this session. So we have discussed the complete 1.5 exercise. So if you are not registered, let me give you an overview for this Sathi JE website. Okay. For those of you who are not registered yet, please register yourself onto this website Sathi JE. You will just Google it. The website will be there. So first of all, if you have any kind of doubt, please join the doubt clearing session related to any subject: physics, chemistry, math, bio. Okay. You can join the Zoom doubt clearing session. Your doubt will be cleared there, because in a live session we do not have much time. Okay. And please do register yourself in this class 11th course here. Enroll for free. Register yourself, and after registering you will get your interface like this. So classes for physics, chemistry, math for 11th will be there, recorded in English as well as in Hindi, with their DPP and notes. Okay, you will find DPP's notes there. Clear? For previous classes also. The whole schedule is there. And if you want to attempt tests, quizzes, if you try to see at the left panel, you will find that there's mock tests related to each subject, topic wise, and then subject wise tests also, subject wise DPP. Clear? So for 11th students, you just go there 11th, pick your subject, mathematics or whatever, the chemistry or physics. And for today's class, so for example, this is your today's class, exercise 1.5. You will find the recorded version of this session here, theory English. And for Hindi, those of you who needs Hindi sessions, the Hindi session will be available here, theory Hindi and DPP and notes. Clear? And in for exercise sessions, we do not have any kind of DPPs, but you can have other DPPs or topic wise. Clear? So please do enroll yourself. Those of you not have been enrolled yet. And if you are facing any difficulty, please do connect with Zoom doubt clearing session. Okay? Clear? So this is it. So we have to end our meeting. So thank you for this session.